What up? Precalculus, Mr. Messner here, coming at you with homework 1.2, where we talk about shapes of graphs, characteristics of graphs. We get into the curvature of graphs. Okay. What we're going to want to do is kind of resist our temptation of um, going in both directions. We are like to look at graphs from left to right. Okay. So it's like we start at the x all the way to the left. We'll call that negative infinity. And then we will travel to the right as we're analyzing our graphs. And we will be able to determine the characteristics of the graph. So, like, here are some things you need to know. Figuring out when the function is positive or negative. When the y values are positive, we are above the x-axis. When they are negative, we are below the x-axis. That's one. Second thing, when is our function increasing or decreasing? Now we start looking from left to right and we can see when our function is going down versus going up, decreasing or increasing from left to right. Always looking from left to right. The next thing we can talk about is the concavity or the curvature of our graph. Now, there's two ways to describe concavity, which makes it tough to understand. We could say the graph is simply concave up until a certain point, probably right around here. It says there's a point of inflection at 0. That's points where our concavity changes. And then we are concave down to about here, and then we're concave up. Now, a way to describe concavity is the rates of change and how they're changing. The rates of change of the function are increasing. Think about the slopes that you would get on this function. They'd be super negative, less negative, 0. So like think -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. Oh, this is probably where we've maxed out. And then we go 4, 3, 2, 1, 0. All of a sudden the rates of change are decreasing. My slopes are decreasing. When your slopes are increasing, when your rates of change are increasing, you are concave up. When your rates of change are decreasing, 4, 3, 2, 1, 0, -1, -2, -3, stopped right here, and then switch. When your rates of change are increasing, you're concave up. When your rates of change from decreasing to increasing, or it's like when your concavity changes, it's called the point of inflection. Okay, so let's keep that in mind. And here's how we're going to answer all these questions. You got to do these by yourself. And if you get any of them wrong, start over. Just start over. Relative maximums are when the graph like goes from increasing to decreasing. You kind of see like, boom, that's where we have a max, where we've humped over. So we're going to say x equals 2. Where do we have a local? Another word for relative is a local. Sometimes we don't care about overall maxes or mins, just local maxes or mins when the function changes from decreasing to increasing. That's here and here. So that's going to be -2 and 4. When is the graph concave up? Look from left to right. Look from left to right. Sorry, left to right. So from left to right, from negative infinity all the way to this point of inflection 0, the graph is concave up. The graph is then concave down. This is curving downward until 3, where we have a point of inflection, and then we go back to curving upward. So 3 to infinity. Again, looking from left to right, negative infinity all the way to 0, and then from 3 all the way to infinity. You can write it using interval notation. You also need to be comfortable writing using inequality notation. X is less than 0. X is bigger than 3 would be negative infinity to 0 and 3 to infinity. When's the graph concave down? That's going to be the interval between the 2 points of inflection, 0 and 3. We are curving downward, okay? Opening downward, thinking of like parabolas. That's how we introduced it. Negative x squared's graph, open downward, its rates of change were decreasing. So 0 to 3, and we can also say x's are bigger than 0 and less than 3. When is the function increasing? Okay, again, look from left to right. Look from left to right. I can't figure out which way I'm going. My function is decreasing till about -2, and then we increase until 2. So that's one interval, -2 to 2. Then from 2 to 4, we decrease, and then we increase after 4. So after 4, 4 to infinity. Again, look from left to right. Look at your graph going down or up. Inequality notation, -2 to 2, and then x is bigger than 4. When is f decreasing? It's decreasing until -2, then it increases, and it decreases from 2 to 4. So negative infinity to -2, and then from 2 to 4. When is the function positive? This is not when is the rates of change positive. If the rates of change were positive, that means the function's increasing. Okay, it's when is the function value positive. This is where we're going to start to get tricky. It's like different kinds of positive. When is the function positive is when the y coordinates are positive. We are positive from negative infinity until -4. Then we have negative values. And then we are positive values up until 4. We're not positive, we're 0 at 4, but then we're positive after 4. So I'd go negative infinity to -4. I would go 0 to 4, not including any of these. I'm using open brackets because it's safe to use open brackets, 0 to 4, and then 4 to infinity. So x is less than -4. X is between 0 and 4, but we're not equaling 4. X is bigger than 4. When is f less than or equal to 0? Okay, inclusion is important. When is f less than or equal to 0? First thing is translating that. What happens if your function values are less than 0? This is when f is negative. You got to be able to translate yourself. Think while you're doing these. -4 to 0, including 0 and -4. So I'm going to use a closed bracket, -4 to 0, to show inclusion. 4, I'm equal to 0, so I will also include 4. You can use like closed brackets around 4 or 4. Less greater than or equal to -4, less than or equal to 0, and then x equals 4. Okay, now, what is the rate of change of f positive? When f's rates are positive. If f's rates are positive, f is increasing. If the slopes of f are positive, f must be going up on average. Okay? If the slopes are positive, f is increasing. Rates are slopes. When slopes are positive, f is increasing. So really, the question is the exact same as E. You have to be able to figure that out because we're going to ask the same question 4 different ways. So I'm just going to say, look at the answer to E. When is f increasing? Its slopes are positive. You can even check, like, when are the slopes positive? When are the rates positive? When are the rates of change of f negative? F's rates are f's slopes. Slopes are negative when the function is decreasing. So it's really the same as question F. Look at question F, and that's your answer. When are these slopes negative? The rates of change are negative. Functions decreasing. Functions decreasing. You can see the slopes are negative. I'm going down. My y's are negative y's per x. When is the rates of change of f increasing? Okay, so this is when the slopes are not positive, but the slopes are increasing. This is the definition of like concavity and concave up. If your slopes, which are your rates of change, are going from -4 to -3 to -2 to -1 to 0 to 1, 2, 3, 4. This is the thing that trips up students the most. If your slopes are going -4, -3, -2, -1, 0, 1, 2, 3, 4, what is happening? -4, -3, -2, -1, 0, 1, 2, 3, 4. Your graph is curving upward. So slopes are increasing means we are concave up. I will say CC up. So concave up, we already answered that. C. So we're asking the same question, just two different ways. You're just got to be ready for it. When is the rates of change decreasing? When are the rates of change decreasing? Here's an example. Well, rates of change are slopes. If your slopes go 4 to 3 to 2 to 1 to 0 to -1, -2, -3, -4, those are decreasing values. Let's think about it. 4 to 3 to 2 to 1 to 0 to -1 to -2, -3, -4. We are concave down. So slopes decreasing, rates of change decreasing defines being concave down. So actually, the answer to L is D. It's just asked differently. Okay. Cool. New function G. The extreme endpoints of inflection all occur at integer values, so we got to like kind of figure that out. What are the local extrema of G? Well, I can see we have like a min where we go from decreasing to increasing. We have a max, and then we have another min. So I'm going to locate those relative minima. X equals -1 is a min, and then 1, 2, 3, 4, 5. X equals 5 is a min. And then our relative maxima, when our graph goes from increasing to decreasing, we'll say is X equals 1. Circle the points of inflection. It looks like we go from concave up to concave down right here at 0. We look like we go from concave down to concave up. I feel like it's got to be here. If you said it was here, I probably wouldn't. It looks like it starts to be concave up right there. So it's actually, I'm comfortable with saying X equals 2. Curving upward, curving downward, switch curving upward to finish off. Okay. We could be curving upward and going down. That's important because now we're going to start to talk about like combinations of things. When is G positive and decreasing? Now, this is important. You have to pay attention to what are they asking for? Are they talking about the rates of change or are they just talking about the function? They're talking about the function G. When is G positive? Its y coordinates are positive. When is G positive and decreasing? Okay, here G is positive and decreasing. So first, negative infinity to -1, I am positive and decreasing. Then I'm positive and increasing. Then I'm positive and decreasing until 4. Now I switch to negative and decreasing until 5. And then negative and increasing until 6. And then positive and increasing. Those are all the things in terms of positive, negative, and increasing together, increasing, decreasing, looked at the same time. So positive and decreasing, negative infinity to -1, as well as 1 to 4. Increasing and concave up. Going up, curving up. It's probably helpful if you draw what that looks like first. Going up and curving up looks like that. So this is like the piece that we're trying to find. Going up, curving up, like that. It's so hard to figure out which way I'm going here. Like, whatever. Going up, curving up from -1 to 0, from 5 to forever. These are tough to figure out, but like it doesn't matter if you're positive or negative. It's just, are you going up and curving up? -1 to 0. Five to infinity. If you are not getting this right, start over. Try again. You have to struggle through these. You have to really understand what you're doing these. I see students that never figure this out and they're just lost. They're lost for forever, honestly, because they never decide to figure it out. Okay, now, different. Look at C and E. I love how we're asking these questions right after each other. G, positive and decreasing. Now it's the rates of change of G, positive. The rates of change of G decreasing. Let's think about that by changing rates of change to slopes. When are the slopes of G positive? Okay, the slopes of G are positive when G is going up, increasing. Whatever. So G is going up. When are the slopes of G decreasing? Again, when are the slopes of G decreasing? Decreasing slopes. 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, 4. 4, 3, 2, 1, 0, negative 1, negative 2, negative. We're curving down. So we are talking about the slopes that are positive and decreasing. Why don't we just combine them? Here are my slopes that are positive and decreasing, like that. 4 to 3 to 2 to 1 to 0. We are increasing concave down. G's slopes being positive means G's increasing. G's slopes decreasing means G is concave down. Okay? So this is increasing concave down, 0 to 1, and that's it. Increasing concave up, increasing concave down, decreasing concave down, decreasing concave up, increasing concave down from 0 to 1. Okay? So, however you figured out, slopes are positive, function's increasing. Slopes are decreasing, the function's curving down. When is the rate of change of G positive? When are these slopes positive? That's when G is increasing. That's it. When is G going up? Here, slopes are negative slopes. We can see I'm going down. The slopes are going to be negative. Here, the slopes are positive. They are positive and increasing. Now they are positive and decreasing. Here, the slopes are positive and increasing. So, negative 1 to 1 and 5 to infinity. I'm just going to leave it in intervals. When is G decreasing at an increasing rate? This is the most confusing one for all students to make. When is G decreasing at an increasing rate? Okay. G's decreasing. G's going down. So we already know that the slopes are negative. G is going down. But the negative slopes need to be increasing. Okay, G is decreasing, but that rate at which it's decreasing is increasing. So the slopes are negative, but the slopes are increasing. Let's look at negative slopes that are increasing. It's not negative 4, negative 5, negative 6, negative 7. Those are decreasing values. It's negative 4, negative 3, negative 2, negative 1. Negative 4, negative 3, negative 2, negative 1. Decreasing at an increasing rate is actually decreasing concave up. When the slopes are increasing, it's just simple to just say when your slopes are increasing, your graph is concave up. So G is decreasing and concave up. Decreasing concave up is from 2 all the way to 5, as well as negative infinity to negative 1. When is G negative? Okay, so that's the first thing. With a rate of change that is negative. So G is negative. Its rates of change are negative. That means G is decreasing. And the rates of change are decreasing. Okay, so start with G being negative. We're looking below the x-axis. When is rates of change that are negative. So rates of change being negative means your slopes are negative, but the slopes are negative and decreasing. So that's like -1, -2, -3, -4. Those are slopes that are negative. G is decreasing. And these are slopes that are decreasing. Now, -1, -2, -3, -4. There, -1, -2, -3, -4 are decreasing concave down. Now, here's an interesting thing. Here's when we are decreasing concave down, but the values are positive. We do not have any values when we're decreasing concave down and negative. We are only decreasing concave up, so the rates of change are negative and increasing consistently from 4 to 6. Again, we're only looking at x values. That's something I probably should have said. So never. You could say G is positive with a rate of change that is negative and decreasing, negative slopes that are decreasing from 1 to 2. Cool. Okay. My calculus students really screw up on like all of this different terminology for the same thing. If your rates are positive, the function are going up. If your rates are increasing, concave up. Rates decreasing, concave down. All right, when is H negative and increasing? Now, this is when H, not when the slopes are negative, but when H's values are negative. Okay, H's values are negative and going up. So again, we're only focusing on X values. We don't care about the Y values. The Y values aren't given to us. H is negative and going up from negative infinity to A, and then from 0 to E. When is H greater than or equal to 0? That is positive or 0. It's not even like increasing or decreasing. It's just when is the values positive. My values are positive from A to C, including A to C and E. So including A, including C, as well as E. When is H concave up? We are concave down until probably a point of inflection at C. We are concave up to looks like a point of inflection at D. So C to D is looking like when we are concave up. I can put this down. When are the rates of change negative? When are the slopes negative? That is when H is decreasing. You gotta just like immediately translate that so you can answer it quickly. Rates of change negative, H is decreasing. Rates of change decreasing, H is concave down. Okay, the rates of change are negative when H is decreasing from B to 0 and from E to infinity. When is the rate of change of H decreasing? When are the slopes decreasing? It's not when is H decreasing. It's when are the slopes decreasing. Slopes decreasing. 5, 4, 3, 2, 1, 0, -1, -2, -3, -4, -5. Let's start with 4. Slopes are decreasing is when you are concave down. You could be concave down and going up, concave down and going up, concave down and going down. Okay. Concave down going up, your slopes are positive 4, 3, 2, 1, 0. Concave down going down, your slopes are 0, -1, -2, -3, -4. Okay, so slopes are decreasing. All it is H is concave up. So concave up looks like C to D. I think we already answered that. Yeah. Oh, wait. Sorry. Concave down. Sorry. I don't know why I said concave up. I was literally showing you 4, 3, 2, 1, 0, -1, -2, -3, -4. That's concave down. Concave down, negative infinity to C, and then D to infinity. When is H increasing at an increasing rate? When is H going up? And when are the rates going up? When are the slopes increasing? When the slopes are increasing, H is concave up. I want to be going up, concave up. Going up, concave up. Going up, concave up, 0 to D. Looks like we're going up and concave up. That's the only part we're going up is 0 to E. Going up, concave up is 0 to D. How many points of inflection do we have? It looks like we have 2, one at C and one at D. Okay, a couple more. For each of the table, determine if the function is increasing or decreasing. Determine if the rates of change of the function increase or decrease. What's really easy about this is you can actually calculate the rates, okay? 5 to 4 to 1. So I go down 1 over 2. I go down 3 over 2. My slopes are negative. My function is decreasing. My slopes are decreasing, -1/2 to -3/2. So slopes are negative and decreasing. So I'm going to write that. Slopes are negative and decreasing. When slopes are negative and decreasing, F is decreasing, concave down. Cool. Yeah. 4 to 6, up 2 over 2. That's 1. 6 to 10, up 4 over 2. That's 2. My slopes are positive. My rates of change are positive and increasing. 1 to 2 is increasing. If my slopes are positive, my function is increasing. If my slopes are increasing, my function is concave up. 4 to 6 to 10. You kind of can see it like 5 to 4 to 1. You can kind of see that decreasing concave down. 4 to 6 to 10. You can see increasing concave up. Here I'm down 3/2. Here I'm down 1/2. My slopes are negative and they're going up. -3/2 to -1/2 is increasing. It's getting closer to 0, about to go to positive. So my slopes are negative but increasing. If my slopes are negative, my function is decreasing. If my slopes are increasing, my function is concave up. You can kind of see 7 to 4 to 3, we are decreasing concave up. 5 to 7 is up 2 over 2. That's 1. 7 to 9 is up 2 over 2. That's 1. My graph is linear. My rates of change are constant. My slopes are positive, but they are constant. My function is increasing, but there's no concavity, which means we are linear. We looked at that before. Okay, now you're just getting words. Here are the slopes, the rates of change. They're negative and increasing, positive and increasing, positive and decreasing, negative and increasing. You got to be able to translate that. Slopes are negative, functions decreasing. Slopes are positive, functions increasing. Slopes are increasing. If the slopes are increased, the function's concave up. If the slopes are decreasing, the function's concave down. So you can, like in this chart, fill it out. F is going down, concave up, going up, concave up, going up, concave down, going down, concave up. You could do that if you want to, but I'm just going to have the translation and just figure it out. But you guys make sure you figure it out, okay? F is increasing when the rates of change are positive. Rates of change are positive here. The rates of change are positive here. So we got 4 to 6 and 6 to 8. Not sure what's going on at 6. It could be 0. It was like, I don't know, like Mr. Huffaker will probably tell you that like we are increasing at 6, but like, I don't know. It's confusing to me. So I'm just going to leave it and you're fine. F is decreasing when the rates of change, when the slopes are negative. When the slopes are negative, you are going down. Okay. So negative slopes, X is less than 4, X is greater than 8. When is F concave up? F is going to be concave up when the slopes are increasing. -4, -3, -2, -1, 0, 1, 2, 3, 4. As long as your slopes are increasing, the slopes are increasing, we are concave up. So less than 4 and 4 to 6. When is the graph concave down? When the slopes are decreasing. 5 to 4 to 3 to 2 to 1 to 0 to -1, -2, -3, -4. So when the slopes are decreasing, go blue. Slopes are decreasing. Boom. That's it. 6 to 8. Where does the graph of F have a point of inflection? When the slopes change from increasing to decreasing or decreasing to increasing. Increasing to decreasing to increasing. Probably at 6 and at 8. That's when the slopes change like direction. The slopes change direction. The slopes change from increasing to decreasing. Curvature is going to change. When does F have a maximum? F has a maximum if it changes from increasing to decreasing. That's when your slopes change sign from positive to negative. From positive to negative, their slopes are going to change. So that's going to be at x equals 8. When does F have a minimum? Minimums will occur when you change from decreasing to increasing. That's when your slopes are negative to positive. Negative to positive, negative slopes to positive slopes at 4. This is a really good question. I like how we ended on this. You got to be comfortable with all of this stuff. It's confusing. So you got to practice. You got to make sure you understand. Slopes positive, functions increasing. Slopes increasing, functions concave up. Slopes negative, functions decreasing. Slopes decreasing, functions concave down. Good luck out there. Try to figure it out. When in doubt, use numbers. I always like to use numbers. You got -1, -2, like you literally have 2 options here. All of this is covered in everything. 5, 4, 3, 2, 1. Sorry, let's just go 3, 2, 1, 0, -1, -2, -3. 3, 2, 1, 0, -1, -2, -3. Slopes are 3, 2, 1, 0. This portion is increasing concave down. 0, -1, -2, -3. This is decreasing concave down. The slopes are decreasing. We are concave down. We could be increasing concave down, decreasing down, concave down. If we go in opposite order, -3, -2, -1, 0, 1, 2, 3. Think about it. -3, -2, -1, 0. Decreasing concave up. 0, 1, 2, 3. Increasing concave up. Those 2 things, if you just write those 2 things down and understand, it's like, here my slopes are decreasing, here my slopes are increasing, and then we got like positive and an increasing, negative increasing. You can kind of figure it out from there. So hopefully that helps you. It helps me sometimes to explain things. Messner's out.